crud. I just now started the recording. I am so sorry. When I had to reopen Open Broadcaster Studio because of a Zoom glitch, and I messed up. That is, yeah, mea culpa. Yes, exactly, Jonathan. Zoom has so many problems. So one of the issues with Zoom is anytime anything farts on Zoom, it kills the camera image for everybody, for Open Broadcaster Studio, for Twitch. So yeah, Twitch is better. Unfortunately, y'all can't talk on Twitch. So yeah, we can go over these problems again. So we have a partial recording. We'll have a segment that's lost, and then, from now on, we will record stuff. Yeah, so we're being recorded from now on. So yeah, sorry about that, folks. I am one person learning a lot of technology in a hurry, standing in front of two laptops and another monitor and an SLR on a tripod and an HDMI capture card, and worried about whether I should shoot at f8 or f4 and whether the studio lights are set to the right Kelvin temperature. I will make mistakes. Please be patient with me as I am. Giovanna, yes, to get the maximum height, right, you want to maximize this separation right here. So there's going to be some point where these two curves are the maximum distance apart, and you can find that using the things you've learned in calculus class. Can we do 1c? So we can. Actually, let's go back and talk through all of problem 1, because there were requests for 1a as well. It turns out there's no quadratic for problem 1. So let's talk through problem 1. I'm going to erase the board here. As you can see, my formerly black shirt is turning rainbow. Let's get these smudges off the board. So what do you all think about problem 1? Yeah, recitation helped for 1, Rebecca, because you did something very, very similar. So here, you know that a stone is being launched at an angle of 45 degrees above the horizontal, and it flies through the air, and it flies in total 2 kilometers. Yes, Laurel. Question 1 is similar to the first recitation problem if you fully understand what's going on. So in this problem, in homework number 1a, we ask, we'll label this as d. We ask what velocity is needed for the stone to fly a distance d. But in recitation, we asked two things. So we said this plus how far will the boot fly? So the first part of your recitation actually is the same as 1a. You're calculating the velocity required to make something go a certain distance. Michael says, could we change kilometers to meters? Certainly. Okay, so is there anybody still here who wants to talk about 1a?
Yes.
Okay, what do you think about 1a? Yes, we can, Shinyi?
Okay. So one, when I did it, I didn't change it to meters because I was stupid and I forgot. So now I did, and I'm going through it, I'm fixing everything,
Mm-hmm.
and I wasn't sure. I want just to check with you to see what did you get so I can make. I mean, not like what I'm supposed to do in order to do it, because what I did, and I separated the x and y. I'm
Okay,
not sure if that was what I was supposed to do.
so what you're saying is you wrote down x and y as a function of time?
Yeah, I did. So here's for the x part, I was trying to find position. I was looking for the position since I knew the position was 2 kilometers, which
Mm-hmm.
was 2,000 meters, and I knew that will allow me to find the velocity, the initial velocity, and then I'll be able to find the time from there, and then I'll be able to put it in the time thing.
Mm.
I don't know if that was right, but I did 2,000 meters equals one half of acceleration t. I mean, acceleration times t to the second power plus v naught times t.
Okay. So let's talk about this. So this is the standard constant acceleration kinematics relation. And
Okay.
the key thing to see here, I'm just going to do a little color coding, is that both x and y have the same form, and they're separate and independent. So what do I mean by that? What I mean is that you've got a different acceleration value and a different position value in x and in y. So let's think about um, what to put in these equations, and I'm going to put in the initial terms too. So both of these are as generic as can be. But for this specific problem, do I know anything about the accelerations or the initial velocities or the initial positions?
What do we know? Okay, for the x, would you know the acceleration is 0, and for the y, the acceleration is gravity, which is negative 9.8.
Yep, so the acceleration in y is g downward, right? So we know that's minus g. And we know this is 0. Yeah. What else do we know?
Uh, with v naught, I'm not sure if this is supposed to be v naught equals, but v naught is v. And that's where I kind of got messed up. I wasn't sure if it was v naught or whatever, but it's v sine theta, which is for y, and then for x, it's cosine theta.
Yeah. So here is my initial velocity vector, but what he has just told me is I can find the x and y components of this, right? So this one would be v naught x is v naught cosine theta, and v naught y is v naught sine theta. Yeah. So right away he has said, you know what? I'm supposed to find v naught. That's what the problem is asking me for. So let me break this vector into its components. Nick has just told me that the initial positions are 0. So Nick has decided that we're starting from the origin, which you can do, right? You say, all right, let's just decree that this position is my origin. Michael has told me what these are, so let's put them in. V naught cosine theta times t. And this one is V naught sine theta. Yeah. And you told me that's 0, so I can just get rid of this with my eraser. And you told me this is minus g, so I can also do this one with my eraser. Okay, so now I've got x and y of t. Now, Rebecca has said x of t is 2,000 meters. But x of t is going to be lots of different values as the stone flies through the air. So, Rebecca, you say x is 2,000 meters. How does that help me solve the problem? You're on the right track, Rebecca, and I just want to hear you articulate, like, what are you going to do at x equals 2,000 meters? What else happens there?
Well, like, that's like your final like position.
Mm-hmm.
So like you're with that you could like do 2,000 equals a net v naught times cosine of 45 degrees, and then times t. But you have to find t first by
Yes.
But yeah, so you find t first by using the y of t formula, which we
Right.
haven't done yet.
Which you haven't done yet. So let me remember how we. So let me. Rebecca said, "I go here and I solve for time." Right? Is that what you're telling me?
Yeah.
And Patrick says, "You go to the x equation and you solve for time." So what do I do? Do I solve for time here or do I solve for time there? Which one is it?
Could you do both?
Yes, both of them are equally valid. So what we're trying to do here, you know how we wrote down those sentences in terms of our variables to give us a roadmap for the problem? I'm going to ask you all to fill in some blanks here. Actually, just do a big long blank. So what goes in the blanks here?
What must t be so that?
I'm going to say t here. So what are we trying to find? What's the...
Okay, we're trying to find the velocity.
Yeah. So we want to know the initial velocity.
So what's the initial velocity so that the position at the same time? No, so that would it be time at the same time? No, or that x of position is the same as y's position.
Yes, so we've got x and y. So there's a certain moment in time when we know both of those. What moment in time is that?
A rest in the air. Oh, yeah, when it's in like the air when it rests.
When it comes back, right? So Maya
Yeah, when it's
says,
the moment of like falling, whatever.
yeah, the moment of falling back to the ground, exactly. So Patrick, we don't actually know how high it gets at the apex. We're looking at that later. But Maya says, so that x equals 2,000 meters, and when x is 2,000 meters, what else do we know? Y equals 0. Yep. So we know that the stone comes back down to the ground after it has traveled 2 kilometers. So different people have told us different things, right? You could either solve this equation for t and then plug it in here, or you could solve this equation for t and plug it in here. Either way will work. So how many of you learned how to solve something called systems of equations in middle school or high school? You did this where you have, yeah, and it was gross. So they give you something like 2x plus 3y equals 4 and minus x plus 6y equals 12. I'm just making things up. And how did you do this in middle school or high school?
You would solve for one variable, and then when you get that, you plug that variable into the other equation, and it should cancel something out.
Yeah. So Kelly just said the way that you do this is you solve one equation for one variable, and then you plug that into the other equation, right?
Yeah, like substitution,
Yeah,
substituting in.
and that technique is called substitution. Did anybody learn a different way to do this?
There's one where you like multiplied it. Like the first will be 1 and the second will be all by 2. And then you subtract.
So where you multiply and subtract. Yeah, both of these are valid ways to solve systems of equations, right? Oh shoot, broke another piece of chalk. Both of these are things you can do. In physics, this is almost always harder. Substitution is almost always the way to go. So this is the happy face, which is what you all told me to do. Solve one of these for t, plug it in the other one. Any other questions about 1a?
Okay. Would the answer for time in that case for 1A would be the same thing that you'll be doing for 1B?
So when you do this for time, that's a really good question because you all were asking about 1b too. So you're going to put stuff in here, right? So this would be, that's the y equation, so that's 0. And that would be the distance d. When you do this, are you going to get a number value for time? Or are you going to get
Yeah,
You are, Kelly?
I think so, right? Because that's what I found when I was doing A. I found T, and that's the amount of time that it would take, like up in the air until it lands.
So you solve that for t. Do you know what the initial velocity is yet, though? Yeah, Laurel, you don't know v initial yet. So when you're solving A, you would get something like, we can do this. We would get, t equals d over v naught cosine theta. right?
So for A, do you just box the answer? Or what would you box? You would box the V naught cosine theta t, and
No,
then that's it?
so for problem A, I mean, we're talking about boxing answers. The point is the process. But for A, you have, this is a question about a real machine, right? There was someone who, Orban, the person in the problem, the Byzantine Empire could not afford, they were fighting for their lives against the Ottomans, and he offered to build them a thing to throw stones, and the Byzantine Empire, the whole empire, couldn't afford the price he was asking to build him a thing that threw stones. So then he went to go work for the Ottomans and built them a thing that threw stones and used it to knock down the walls of Constantinople. Then it was conquered by the Ottomans and became the city of Istanbul. Right? That's the pivotal moment in history that this problem is about. But there's a real answer, right? There's a real answer of a number that's how fast these rocks came out of the thing. We'd like you to find it. It's over 100 meters per second. It's a big value. So yes, Rebecca, you actually will get a numerical value here. But you can't get one for the time in part A because you do not know V naught yet. But for part B, you do. Because in part A you found V naught, and then for 1B, you can plug V naught into here and find the time. Rachel says, when I say G, am I saying plus or minus 9.8? G is always a positive value. We know, though, that gravity pulls things downward. But I could choose that coordinate system, couldn't I? And in this case, the direction of gravity would be positive. So here, this symbol G always stands for a positive number. And if this is in the negative direction, I have to put a minus sign in front of it. So the acceleration here is minus g because g is a positive number. Does that answer your question, Rachel? Yeah. So this 1a, 1b thing, for 1a, you're going to have to get this expression, an expression for t. You can get something from either equation and then plug into the other one to find the initial velocity. And then for 1b, you have to substitute back into that expression for time to find the time. So there were some questions about the other parts of number 1, right? 1c and 1d.
Yeah, I had a question about 1c.
Okay, Meredith wants to talk about 1c. So let's make all this go away and get ready for that. So Meredith, what's your question?
Okay, so I'm kind of confused because it wants to know. Oh, wait, okay. So, well, wouldn't I just divide the time by 2?
Ah, okay. So why would you divide the time by 2?
Because when the thing is at its apex, then it's like exactly 1/2 in the middle of the parabola.
Yeah. So
and if the whole bottom line is time,
well,
then 1/2 of that.
Yeah. So how do we find the apex? So what Meredith has suggested is first is that it's halfway through the flight. And this is true because of symmetry. Because this piece, which I'm highlighting in blue, and this piece, which I'm highlighting in green, look the same, right? That's your logic?
Yeah.
Yeah. Does that always work? Patrick, hold on to that thought for just a moment. No, it doesn't, Dinara. Why doesn't that always work?
Because the city Constantinople is not equal to 0. It's slightly above the ground, above the x-axis, right?
Yeah, and so in this problem, we're kind of assuming that this is reasonably flat, but the height of the walls of Constantinople is small compared to 2 kilometers. But in general, right, suppose I'm throwing a snowball up on top of a building, and it goes in this path. Well, here, the apex is there. So what you have proposed to do works for this problem, right? This is fine for this problem because you have symmetry, but in a different sort of thing, that doesn't always work. So here you can divide the time by 2, but you can't always.
Wait, I have another idea.
Sure, Meredith.
Okay, so what if you replace, like, the equation? Well, I don't know, like, if other people did this, but I did, like, x of t equals initial velocity times cosine theta times t. And I set that equation equal to 2000. So, but then, like, for this, could you just set it equal to 1000 for, like, half of the distance?
So that's a variant on number 1, right? Basically, you're saying I could either take the halfway point in time, or I could take the halfway point in distance in x. Both of those would work. I think Patrick has another idea that would also work. So Patrick says, wait, if this is going in a parabola, doesn't the apex signify when the projectile goes from going upward to downward, which does something special to the velocity? Yeah, what special thing is that?
Hold on.
It would be 0.
Which velocity? Got 2, remember?
The vertical velocity 0.
Yep.
Yeah.
Yeah. That works too. And this is more general. Like here, Vy is 0, even though we don't have symmetry.
So, Professor, does that mean that that's our answer?
Not quite. Because here, what am I asking for about the apex?
The speed at which it's traveling, the object at least.
The speed, yeah. So we want to know at the apex, and remember we saw 2 ways to find the apex. We could either do the time Vy is 0, or we could do halfway.
Would the speed be unchanged from the initial speed since there's no acceleration in the x direction?
When you say speed...
Oh, that's velocity. Sorry.
So speed is magnitude of velocity.
Yes. Okay.
So what we want is the magnitude of v. Does this mean vx or vy?
90.
Wouldn't it just be for Vx?
So you're right in that only Vx is left.
Yeah.
But let me draw this bigger. So we're going to erase this picture and just make it bigger. Here, if I think about the entire motion, it goes like this. And if I draw the velocity vector at different points, right? Which of these points do I want?
That middle point.
This middle one, yeah. And here, what's the value of Vy at that point?
0.
Yep. So at the apex, Vy is 0. So how do I find the magnitude of the velocity? How do I find the length of that little green arrow at that spot? I'll let you ponder that. Remember, so actually somebody said earlier.
Did we cover this at the end of our last class?
Briefly.
Yeah.
Shruti, it'll be on YouTube. Shruti, the recording, there was a piece earlier that didn't get preserved because of a Zoom plus me glitch. But the recording that we have, so this and everything that we do going forward will be on YouTube. So Anna Carroll says you'd have to find t. So you could say, all right, I know Vx of t is V naught x plus axt. Vy of t is V naught y plus ayt. You could do that. Now, you know this one will come out to be 0. But I'll let you think about this a bit more. So these are the standard constant acceleration relations for velocity. I'll let you think about which of these terms are 0, which of these terms are non-zero, and ponder what to do.
Would you do V equals the number that we found, the 141, plus AT, but wouldn't A be 0?
Careful.
I'm not sure.
So Kelly has worked out that the answer to 1a is 141 meters per second. So this is the initial velocity vector, right? Its magnitude is there, and it has x and y components. Now, which of those is 141 meters per second? Which of these did you find for problem A?
The initial velocity, the one on the hypotenuse.
Yeah, this is the one that you figured out was 141 meters per second. What are these going to be? Well, something else, right?
So would I take the velocity x and like have it as cosine 45 and multiply by 141?
Yes.
Did you just use Pythagorean theorem?
Yeah, so to find the magnitude of a vector, yes, you use the Pythagorean theorem. So this is what you have in the beginning, right? So this is the initial velocity. But at the apex, what direction is the velocity vector?
It's like horizontal.
It's horizontal, yeah. So this is the velocity at the apex. And so here, you'd have to use the Pythagorean theorem, right? So you'd say v naught squared is v naught x squared plus v naught y squared to find the magnitude. But what's the magnitude of this vector? This is a trick question.
141.
Careful. Not the number, but here I've got an x component and a y component, and I have to use the Pythagorean theorem to figure out the length of that arrow.
Wouldn't that just have an x component?
Yeah, it just has an x component. So here, the magnitude is just Vx at the apex, right? So Dinara, you have said V naught x. You've said in Zoom chat that the magnitude here is the initial value of Vx. How did you get from saying that the initial value here, this horizontal length, is the same length of the velocity vector at the apex? How did we get there?
Because y component is equal 0, and
So the y component is 0 here, but how does the x component of the velocity change as the thing flies?
can you repeat that again with the question?
Sure. So if we draw some little diagrams here, I'm going to clean this up a bit. Right? All throughout the motion of this thing, its velocity vector has both x and y components. We're going to draw them in blue and red. So in the beginning, its x and y components of its velocity look like this, right? And there's a right triangle over here that tells you how to work this out. And as this thing goes through the air, the components of its velocity change. Here, there's only an x coordinate, right, as you all told me. Only an x component, rather. So what we need to do, we need to figure out the length of that arrow up top. And what you all have told me is that its y component is 0. But now we need to figure out the length of the x component. How am I going to do that? Because we know in the beginning, right, we worked this out in previous parts. We worked out this. So this is just v naught x. That is just v naught y. But I don't want this one. I want that one. So I'll leave it up to you to think about how that changes during its motion. What else would you all like to talk about?
Can you go for number 5?
Can we talk about number 5? Sure. We'll do number 5 and then we'll do number 3. And I know we did number 4 earlier, but that one's I'm happy to repeat things, by the way. If people want to talk about number 4 again, we can do that one again for the people who've just arrived. Again, I'm sorry that it's not going to be on the recording. That was my bad. But I'm happy to talk about it again. Okay, so the request was for number 2, I believe, a question you wanted to do. Oh, sorry? Bridget says number 3 because we haven't done that. So yeah, let's talk about, oh, right, Shruti wanted to do 5. So let's talk about number 5 because it's related to number 1. So number 5 says you've got a slope, and the slope has an angle of 45 degrees. You have a hiker standing on top of the slope, and they kick a stone off, and it lands somewhere down here. So we've done a bunch of problems trying to understand projectile motion, right? How are we going to understand this? How are we going to calculate where that is? How is this the same as asking, as the other problems we've done, like the one you did in recitation today, asking how far her boot goes? How is it different?
You're not on like a level surface to start off with.
Yeah, it's not on a level surface. So before, right, in a level surface, right, so when you had something like this, you said, okay, if I'm trying to figure out when something hits the ground, that would translate to y equals 0. But here, you don't know, without thinking about it, how to mathematically say thing hits ground. Any ideas?
Since it's a 45-degree angle, would the kind of the distance forward be equal to the distance down?
Yep, exactly. So what Ryan pointed out is, you know this is a 45-degree angle, right? And you know that right triangles with 45-degree angles are isosceles. So, Ryan, I like the way you put it. You use terms like distance forward and distance down, which kind of give you a picture in words of what's going on. So here, we'll label this as distance down. And here we'll label this as distance forward. Because that is 45, this is an isosceles right triangle. So that should suggest another condition that means thing hits ground. Person who asked for number 5, does this give you the nudge you need to figure out what to do? That was you, right, Shruti?
Yeah, kinda. So would you use like the tan of like, is this where you bring tangent into this question?
So you could, right? So, you know, since that is a 45-degree angle, you could write that the tangent of 45 degrees, well, that's going to be opposite over adjacent. So equals the distance forward over the distance down. But what is the tangent to 45 degrees?
1.
1. Yep. And so if a fraction is equal to 1, what does that tell you about its numerator and denominator?
They're equal?
They're equal. Yeah. So when I wrote this problem, I set this up to minimize the amount of math you have to do.
Thank you.
Okay, Lucy wanted to talk about question 3. So this is the one where Kiki is trying to jump up and the real Kiki, when the real Kiki was jumping at stuff, she was jumping at the little peephole on Lindsay's door. It was the funniest thing I've ever seen. She'd just like stand in front of the door of this tiny little black cat and jump, straight up in the air, like 5 feet, and smash this thing, thinking it was a bug, and try to eat it. It was so cute. So here's Kiki. I don't have black chalk for obvious reasons, so Kiki will be a green cat. And what do we know? Well, we know she goes straight up and back down to some height (150 centimeters). So the question is, well, we want to know what initial velocity is needed to carry her to that height. How are we going to do that? So Lucy, you said your answer didn't feel right. What did you do, and what didn't feel right about your answer?
Okay, so I tried to isolate t for both equations and then set them equal, but I don't know, I had a whole bunch of stuff and then I erased it because a canceled out and then I got 1.7 meters per second. And I don't know if that's right.
So let's start. You said both equations. What equations did you have?
V equals VO t, or no, it's V equals VO plus AT, and then delta y is VOT plus 1/2 of AT squared.
Okay. And what do you know about the things in these equations?
Well, I think you can isolate variables, and then because they have some of the same variables,
Mm-hmm.
and then you can set them equal to each other.
So there's a crucial sort of thing here, which is how do you pick out the point up at the top of Kiki's jump?
That's y equals 150 centimeters.
Yeah, so we know y equals 150 centimeters, but suppose Kiki is like the Michael Jordan of cats and can jump much higher than that. Well, Kiki's still going to get to 150 centimeters. We want the special magic velocity that carries Kiki 1.5 meters up in the air, but no further.
Oh yeah, velocity, the final velocity is going to be 0.
Yes, right. So we need y equals 150 at the same time that...
We do 1.5 meters.
Yep. At the same time that v equals 0. Right. So that's all you need. Rebecca, yes, we can. So it sounds so. This is what you did, Lucy.
Yeah.
And why do you suspect that there was a problem here?
I don't know. I'm not really sure like which equation to use. Like, do I use both of them and like combine them somehow? Or oh wait, can you use like the first equation and like put v final is like 0 and then like just solve for that because we know acceleration is negative 9.8.
Yeah, that's exactly what you do.
But like then you just find time and that's part B,
Mhm.
I think.
Yeah, so this is another one of those systems of equations that you best solve by substitution. You go to one equation, right? You've got, let's erase this and put in the things we know. All right, so the velocity is 0 at the same time as the position is the height that we know. So solve either equation for t and plug it into the other one. So which equation is easier to solve for t?
The top one.
The top one, yeah, because this is a quadratic and nobody wants to do that. So yeah, just solve that for t and plug it in.
All right.
Okay, Rebecca wants to talk about number 2. Are there any more questions about number 3?
Wait, can I take a screenshot?
Sure.
Thanks.
So, Akweshi wants to talk about number 2. Rebecca wants to talk about number 2. What do you all think about number 2?
Is it okay if I ask a really quick question?
Sure.
So I've just been working through a bit of 1C, and do I have to worry about gravity is my main question, because I have an idea of how to solve it, but the answer to my question kind of tells me if I'm right or wrong.
So gravity exists.
Yeah.
And you will, so let me put it this way. Gravity is the reason that the stone doesn't keep going up, right?
Yeah.
If there were no gravity, the stone would like float up into space.
Yeah.
So yes, gravity is present and does stuff, and you'll need to think about how that works. Okay, that was a bad idea.
Because the equation that I ended up finding in the back of my notes was v is equal to the square root of vx squared plus vy squared. And then...
So that's true, but those things are always changing, right? We'll come back and pick up 1C after we talk about number 2. We got a couple of requests for number 2.
No worries.
Yeah, so we'll come back and pick that up in a moment. So what do you all think about number 2? Rebecca, Akweshi?
I was just I wanted to confirm how to set it up, what we're looking for.
Okay.
And for A, it says how fast was Teddy moving when he left the platform.
Mm-hmm.
So I think is what is the initial velocity?
Yep.
When y over t equal to 2 meters, because that's how high above he is.
Yep. So Teddy will be an orange dog. It's a very happy orange dog with a tail. He goes out there, right?
Right.
So yes, there is some initial velocity that you don't know. What else did I tell you? 2 and 6, yes. So you know that distance is 2 meters, and that distance is 6 meters. So yes, we want to know the initial velocity that makes Teddy land here. So Teddy is actually going to take this path, but with different values of initial velocity, Teddy might wind up there or there, and we want the one that makes him wind up there.
Why does he land in 2 different places, or is it just the possibility?
These are the possibilities, yes. The reason I did this is there's a magic value of the initial velocity where Teddy lands on top of his favorite ball.
Mm-hmm.
If he didn't jump as fast, he'd go here. If he jumped faster than that, he'd land here. So we got to figure out what value of v naught takes him to this spot.
Okay. But since they said when he left the platform, that's why I was like when yt equal 2. But you're saying we should say it when x of t equals 6 meters instead?
So this is a thing. When you say y of t equals 2, let's talk about coordinate systems. What place in our diagram are we going to choose as x equals 0?
The bottom corner.
Okay, so you want to choose this as your origin, right?
Right.
So this spot, the spot that Teddy leaves from, what are its coordinates?
0, 2.
Mm-hmm. Which I'm going to write as 0h. And what are the coordinates here?
6, 0.
Yep. Which I will label as D0. So that will likely help you. You know that he starts here, he ends there, and you have to find the initial velocity that makes him go through that point. Rebecca says, so you know height and distance. So Rebecca, I saw your comments a bit ago, but I wanted to ask Akweshi what coordinate system we wanted. So yeah, at some point, x is going to be 6 meters. And at that same point in time, y is going to be 0. So you have to figure out what value of the initial velocity makes x equal to 6 meters at the same time as y equals 0.
All right, yeah. So I was confused on how to like set it up, but I guess that makes more sense.
So let me give you a kind of a caution here. So sometimes physics students say, yeah, like setting the problem up is the part that I can't do, and then after I can set it up, I'm fine after that. Well, setting up problems, that is the physics. So don't overestimate how important algebra is, and don't underestimate how important being able to go from words to picture to equations through numbers are. So the words to pictures to equations, that's important. So what did we do? Am I still in the frame? Sort of. Well, no. So we started with the words description, right? This is the step that I did. We then are going to go from here to equations, right, which is and you'll need all 4 of these for different parts of this problem. So often when you're trying to figure things out using physics, you need all parts of this cycle, right? You have to start with an explanation in words. You have to figure out a diagram. Based on that diagram, you have to figure out some mathematics, and then you'll need to do that mathematics to calculate numbers or solve for the things that you want, right? And this process is algebra. And what I found is a lot of students think that this is the important arrow, but it's not. Algebra is something that we have machines that can do that. And we've been doing since the 6th grade. So often students think, oh, this is the important thing. This is the thing that I do in math class. But the real important parts of physics are this arrow. So figuring out how to take a description of something in words and make a model. And then understanding the laws of nature to go from a diagram to equations and ask the right question. There's even another one that goes back here, where you take the things you have calculated and draw conclusions from them. And this arrow is really, really, really important in engineering. You calculated a thing, now you have to decide what to build. So don't overestimate the importance of doing the algebra.
All right.
That's my rant.
Yeah, and then for part C, for number 2, like for direction, do you want like, what do you specifically like want? Like,
Okay. So based on the things that appear in our equations, how do I find the direction? So when Teddy, who is completely adorable, gets over here, his final velocity will be going like that. How are we going to figure out Teddy's final velocity? So Miles says trig. What do you mean by trig? You're right, but what do you mean?
SOHCAHTOA.
SOHCAHTOA. Yeah. So I think what Miles is getting at is our equations tell us components, right? Our equations would tell us the x component of the velocity and, oops, didn't draw that right, and the y component of the velocity. So if I know yellow arrow and blue arrow, how do I find pink arrow?
Pythagorean theorem again?
Pythagorean theorem, yeah. So let me color code this. I've got two kinematics relations that tell me yellow arrow and blue arrow. And I can find the length of the hypotenuse, that is, the magnitude of the velocity, using the Pythagorean theorem. Whoops, that's just v. So let me erase this and kind of take notes for you all here. If I want, how shall I write this? If I know the components and I want to find the magnitude, what did you tell me to do?
Pythagorean theorem.
The Pythagorean theorem, yep. If I want to go from components to the direction, which this question also asks you, what do you do? So direction here would be trying to find that angle.
Is it inverse trig functions then?
An inverse trig function. Which inverse trig function? There's one in particular that's really helpful.
Tangent?
Yep. But what if I want to go the other way? Let's just complete this little diagram. What if what I know are magnitude and direction, and instead I want to find the x component and the y component? What do I do? So let me just put the diagram back up on the board. So I've heard from the TAs that some people Would appreciate a trig review. Oh, I got my colors backwards. That's okay. What kind of trig do I do? So tangent is not super helpful, right? If I know the magnitude, thank you, Louis. Vx, Vy, and the angle. How do I get from V and the angle to the components? What trig do you do?
Well, if you have the angle and V, to find Vy, you would use sine, and then Vx is cosine.
Yep. Now, be careful. You can't memorize y is sine, x is cosine. Because if I had instead given you this angle, they would be the other way around, right? You always have to think. But yeah, you use sine and cosine to go from magnitude and direction to the x and y components. But to go from components to magnitude and direction, you use the Pythagorean theorem and the inverse tangent. Shania asks, do you also use trig for 2a? You don't need to. Because when Teddy leaves the platform, may I erase this? When Teddy leaves the platform, oops, this is water. Water should be blue. Here's his favorite beer bottle. His initial velocity vector is straight horizontal. Shania. So you don't actually need to do any trigonometry here for part 2a because this vector is nice and straight. Now, Shania, I think what you may be thinking is this triangle is somehow relevant. Is that what you're thinking? So that if Teddy were a laser beam and went straight through the air, then yes, you might care about this triangle. But this is actually not important because Teddy doesn't travel along that path. Yes, exactly, Shania. That's not important. Teddy travels along this path. And so you're going to have x and y as functions of time and do the things we learned to do. And yes, I know I've got chalk dust all over me. Maybe a black shirt wasn't the best idea today, but that's fine. Any other questions people would like to ask?
I know that this has already been asked, but I wonder, could you do actually? Wait, give me a second.
Sure. While you're talking, I'm going to. I think my headphones might be getting slightly low on power, so I'm going to see if there's a way for me to plug them in. We got a question for 1D. Dinara missed number 4. Aqueshi says, do we still have to do 4D? There isn't a part D. Oh, 1D. Yes, we didn't talk about part 1D. So let's do that one. And yes, Dinara, then we'll do number 4. For the people who are just joining, we did problem 4 much earlier, and we talked about it in a lot of detail. But I messed up, and I didn't have the recording on. because something about Zoom meant that I needed to restart Open Broadcaster Studio, and I forgot to push record again. So we'll do number 4 again. But so let me ask you a question while we're setting up for. Yes, Dinara. Problem 4 is hard. It's the hardest problem on this homework set. Brian, it will be posted to YouTube as soon as I hit stop here, and as soon as I take my headset off and eat another peanut butter and jelly sandwich, of which I've already had 2 today. I'm kind of living on peanut butter and jelly sandwiches. I will shovel this up to YouTube. So yeah, the whole recording is going to get posted as one big block. No, I'm not Uncrustables. Okay, I at least can make my own peanut butter and jelly sandwiches. I like to cook, but I don't really have time to cook much these days. So 1D is asking you to think about this 8-meter long cannon that we're propelling rocks out of. Right, so here is a stone, and its velocity here is 0. But by the time the stone gets to the end of this, its velocity is some big value, which you found in 1A. So what you'll need to do is you'll need to figure out what acceleration is needed down the barrel of this cannon to make it go from v equals 0 to over 100 meters per second over 8 meters. And you know, right, you've got equations for position as a function of time. And you've got an equation for velocity as a function of time. Now, this is another one of these situations where you've got 2 equations. They're a system of equations, and you'll have to solve them by substitution. Right, because here, you know something about how the position and the velocity change. You know the velocity at the beginning and the end, and you know the position at the beginning of the end. So you know this, but you don't know the acceleration, right? And you also, I'm just looking for a different color chalk, you also don't know the time. So this is 2 equations with 2 things that are unknown. And you'll need to do the thing that you always do here, which is solve one equation for one variable and plug it in the other. So that's 1D. Any further questions about 1D?
Could you just use like the final velocity squared equals the initial velocity squared plus 2 acceleration times distance?
You want to use this?
Yeah.
Okay, so let me let you in a little bit behind the curtain. This homework set is shorter than it was last year. So I sometimes give the same homework problems in successive years. I spent a lot of time writing these, and so I reuse them. But I wanted to make this homework set shorter since we're like down a day because of COVID. Originally, the first problem on this homework set is to figure out where this came from. Where do you get this formula from? Well, it turns out it's a consequence of the other 2. That if you take these 2 equations and you don't necessarily assume you start from rest, solve one for t and plug it in the other, you will get this. And so yeah, you could use it. It's true. And in the original version of the homework, you just derived this. You just figured out where it came from. Yeah, I mean, I don't really care how you do problems, right? In your recitation on Friday, you will figure out where that comes from. So Anna says, is x 0 or 8 when you plug in stuff you know? Well, again, it depends on what moment in time you're thinking about. At this point, right, if we want to think of this spot as our origin, here x equals 0 and v equals 0. But at here, x equals 8 meters when v is whatever it is leaving. So this is a case where you've got to kind of think about how to get your mathematics to give you what you need, Anna. Laurel says, once you solved 1 for t, how can you then solve for a? I'll let you take a crack at that. It turns out, so in this equation, right, you know everything but time and acceleration. So you solve 1 for t, you stick it in the other one, and then the only variable left you do not know is acceleration. Thank you, Michael. Thank you for coming by and spending time with us doing physics on a Wednesday evening. So let's talk about number 4. Because I am actually very tired. I'm going to have to go at 7 or shortly thereafter so I don't fall over. I don't want to myself become a physics problem, and I have to finish writing your quiz. There's a cat problem and a dog problem on your quiz, and I've written the cat problem, and I'm still working on the dog problem. Anybody who wants to send me pictures of your pets doing stuff, like, don't just send me a picture of your cat. Send me a picture of your cat and tell me what your cat likes to do, and your cat will also be on homework or exam problems. So I'm using cats of people who've helped teach the class before. So problem 4 is the one where we put Kiki in an elevator, and she is jumping up trying to hit the button on the wall. So here's the elevator. Oh, we'll draw it here. There's a button on the wall. I believe it was 135 centimeters off the ground. I don't have any black chalk, so we'll use green chalk for Kiki. Here she is. I'm sure you approve of my art. So we know Kiki can jump 150 centimeters straight up into the air. And you calculated in problem 3 how fast she had to push herself off of the ground to do that. So we know Kiki will go up in the air to 150 centimeters and come back down. But in this problem, does that mean that Kiki can necessarily hit the button in the elevator? What's the funny business that's going on?
Acceleration upwards at 2 meters per second on the floor.
Yeah, it's accelerating up. So that means that as soon as Kiki leaves the ground, right, this button is moving up out of her reach, perhaps. So our challenge in this problem is to try to figure out how we can phrase, does Kiki catch the button, in terms of math things. So how do we turn does Kiki catch the button into a statement about mathematics? I'll get out of the way of it.
I don't really know about that, but would this mean that like your acceleration, like your gravity acceleration, would go from like 9.8 to 11.8?
So it turns out that, so this is actually a very profound thing. Let me ask you, why did you say that? What motivated you to make that statement?
Well, the moment she jumps, the elevator will be accelerating up at 2 meters per second, but gravity will also be pulling her down, and those forces are like going towards each other, so like they kind of combine, I would think.
Yeah, your intuition is completely correct. Ryan, was that you talking? Who was speaking there?
Yeah, that was me.
Yeah, sorry, I've got like I only have two monitors, and I have to. Sometimes I don't always have the names on top. Your intuition is completely right, and that's what you'll find in the end, that you wind up adding the accelerations together. But that's the ending point, not the starting point of the problem. You can't just assume that. You got to get there. But your intuition is right, and that means you know what the answer ought to look like when you get there. So how are we going to frame does Kiki catch the button in terms that we can make mathematical and then solve? Okay, Rebecca says, Rebecca's asking something about 2. Yes. Yes. It will be another system of equations. It's almost like understanding how to deal with systems of equations is an important thing, and I've cooked up a lot of problems to get you practice on that. No, don't apologize, Rebecca. There are no unwelcome questions in Physics 211. I feel bad when there are questions flying by on Discord that I can't answer all the time. Yeah, at some point I have to do things that are not teach physics. But yeah, this class is set up for you to do exactly this. I do not write the homework for you to go in a cave and do on your own. I write the homework for you to do with one professor and 8 graduate students and 25 undergraduate coaches and 400 fellow Physics 211 students to help you with. This is not a solo class. Rant aside, back to our thing. How do we make mathematical does Kiki catch the button? What is why? Yeah, so Dinara, exactly. This is the same skill we've been practicing, right? We need to think like, okay, what value of y, so on, so on, so on. So we need to write some kind of sentence that's got x's and y's, although in this problem there are just y's because things just move up and down, that's got y's and time and things like that in it that we can then turn into an equation. What is y when v Kiki is 0? Okay, that is a tempting thing. Let me draw a graph for you. I'm looking for a piece of white chalk. I know I have one. I have another box of chalk on order. There is a legend among mathematicians that this particular kind of Korean chalk, you can't write wrong mathematics with this chalk. Mathematicians are superstitious people. So we know something about Kiki's path. We know that Kiki can jump up and come back down, and that the maximum height of Kiki's jump is 150 centimeters, and I'll get out of the way. Let me move the camera so you can see that. So this is what we know. And we know the elevator button starts at 135 centimeters. Let me just revise this drawing so the two scales match. So we know the elevator button starts here, and Kiki makes it up to here. Boop. So that's where the button starts. But, and as Dinara has said, we know the apex of Kiki's jump is here. V Kiki equals 0. I should label my axes. This is time, and this is height. But does this picture that I have drawn here necessarily mean Kiki catches button. How's the button gonna move? Upward, yeah. So what kind of graph should I draw here? Is it a straight line? Is it a curve?
Be like a curved concave up.
A
That high.
a concave up curve, yeah, because it's accelerating. Now, at this point in the problem, I don't know how to draw this graph. Is it like that? Question mark. Is it maybe like this? Question mark. I don't know. That's what you got to figure out. You have to figure out whether the graph is like green curve or like blue curve. Now, again, I've drawn the graphs for you, but a really important skill that you will have to develop is the ability to kind of go from here are the words to this is a thing we got to figure out. Now, this problem is not easy. This is the hardest problem on this homework set by far. And every year I have given this problem, it provokes this sort of conversation. So I'm not chastising you for asking this because every year everybody asks about this problem. It's here to give you things to think about. How do we sort out which one it is? I know y'all are tired. I am too. Go ahead, Denara.
We need to find the velocity of the button moving upward and the position of this button when
Yeah, when you don't. Oh, go ahead.
When a Kiki on the maximum of her height.
Well, be careful. It turns out the maximum, only knowing the maximum is not good enough, because I've drawn a graph here where, like, look at the red graph.
Yeah,
Kiki catches the button, but is still below it at the maximum point of her jump. But what you said is exactly how to approach these problems. If you have a problem where you don't know what to do, write down position and velocity as a function of time. How many position versus time graphs am I going to have?
2.
2. Why?
1 for y and 1 for x.
So in this problem, the only motion we have is up and down. So there's no reason to write down an x equation because nothing moves horizontally. But you still need 2 equations. Why is that?
Oh, 1 for Kiki and 1 for the elevator.
Yeah, 1 for Kiki and 1 for the elevator. So
two variables.
Say again?
Yeah, we have 2 unknown variables.
Mm-hmm. So I have a function for Kiki as a function of time, and I have a function for the button as a function of time. Can I write down equations for those 2 things? Yeah, I can do that. I know how to do that. For both of them, right, I'm just making sure that I'm still on the frame here. Whoop, my colors are off. Let's see, Kiki is green. So I have y Kiki of time is where she starts plus her initial velocity times time plus, well, my writing is crooked because I'm above my head. Now, I'm going to do something funny here. I'm going to write the time variable wherever it appears in blue. And that might be important later. Actually, I'm just going to change a lot of the colors here. You'll see why. If you ask me to do certain things, it's going to be important that I have changed these colors. So now we'll do this for the elevator, or the button. It's going to be y0 button plus the initial velocity of the button plus the acceleration of the button. So sorry it took me so long to get my colors right. Here are my two equations. One tells me where Kiki is as a function of time. One tells me where the button is as a function of time. Now, with sort of two ways we can continue here, right? I can either start asking if I know any of these things, or I can think about what I'm going to do with these two equations now that I have them. Which would we like to do?
Cross out some variables.
Yeah. Okay. What do I know about these variables?
For example, y0 Kiki is equal 0.
Okay. Why is that?
Because why is that?
She starts on the ground.
Yeah, and this is where we're considering y equals 0. Yep. Okay. What else do I get rid of, or what else do I know?
An elevator also, probably, because we all start from one coordinate system.
So be a bit careful here. When we write the elevator, are you talking about the button on the wall of the elevator that she's trying to jump up and hit? Or are you talking about the floor of the elevator?
I'm thinking about floor elevator, but we should consider a button, right?
Yeah, because the button's the thing she's trying to get, but we're going to need to think about the floor a little bit later. So let's draw that in too. So yes, the floor also starts at 0. But what else here do I know?
So button is the height. Yeah, that's 135.
Yep. Now, I like to label things with variables and put numbers in only at the very end. It makes life so much easier. So I'm just going to label that as h. Is there anything else I know? Gravity. Yeah, what about gravity, Megan?
For y of k or Kiki, that would be a would be negative g.
Yep. Because once she leaves the ground, she's in free fall. No force other than gravity is acting on her. Okay. What else do I know?
Don't you also know? Oh, sorry. The acceleration of the button.
Yeah, that's a thing that you know in the problem. So this is known. Okay. Anything else? We haven't talked about the velocity terms. Do we know anything about those?
for velocity of Kiki, wouldn't it be the same number that we get for number 3, the answer?
Yep. Right, you just found this. So that's something you know. Right, we figured out how jumpy Lindsay's cat is. One thing left to think about, which is the initial velocity of the button. What about it? Is it 0? Yeah, Megan. Because, so you might say, wait a minute, it doesn't have to be 0 because the elevator might already be moving when Kiki jumps. It turns out it will cancel. So if the elevator is already moving when Kiki jumps, then its velocity will be added to Kiki's velocity as well, and it'll cancel. The way we've drawn it, though, the elevator starts from rest. So this you can also treat as 0. So what we've kind of outlined here is when you don't know what to do for any sort of problem, graph stuff and write down your equations of motion. So what I'm going to do now, so any questions about how we got any of this before I clean it up? Okay, so I'm going to erase the things you told me are 0. I'm going to erase the other thing you told me is 0. And I'm going to erase the reminders that we know certain things. Okay, so now what I've done, remember we talked about the process of solving these problems as words to diagrams to graphs to equations. Now we have some equations, but we're still missing the most important step, which is how do we get the question of does Kiki catch the button on the side of the elevator out of our math? How are we going to do that?
So first we have to like equal them to each other and then do the quadratic formula.
Yeah. What are we setting them equal for?
Because we try to figure out if they met or not.
Yes. So the question we are asking, which I will attempt to write up at the top of the board, is there a value of t such that these are equal? I'm out of colors, such that y Kiki of t equals y button of t. So we would set them equal. Now, you said you have to use the quadratic formula. How did you know you had to use the quadratic formula?
Because if you equal them to each other and then basically switch it over to all on one side, it's going to end up being like a quadratic. So you have to do the formula.
Yes. So you did the math, right? You set them equal. You put everything on one side, and you get a quadratic. Now, I'm not going to do all of the algebra. There's still some problem left for you all to do. But notice that when you set them equal, well, we'll do this. It's pretty trivial. You're going to get h plus 1/2 a t squared equals this one. Equals v naught t minus 1/2 g t squared. So that's what you get when you set them equal. But I thought a quadratic was supposed to only have 3 terms. This equation has 4 terms. What happens?
Oh, we just need to plug in numbers and solve this.
You could, but you've got 4 terms here, and the quadratic equation only has a, b, and c. It doesn't have a, b, c, and d. So what happens to this equation when you put everything on one side? Yeah, Megan, the t squareds go together. So you tell me, what do I write down for my next line of algebra? Right, Lucy?
Wait, how do you combine the two t squares without them canceling?
So if I've got, say, 3x plus y squared equals 12 plus x plus 2y squared, what do the y squared terms do in this equation?
Wait, do they add together?
They add together, yeah. So you've got the same sort of thing here. You've got a t squared on the left and a t squared on the right. So these two combine. So tell me what my next line of algebra should be. So Dinara, I'm not going to plug in yet. I'm allergic to numbers. They make me break out in hives. And I also... Oh, go ahead.
Should you set it equal to 0, like move everything on the left side over to the right?
Yep. So tell me what to write.
So write just 0 equals, like, wait, would the 2 halves cancel out because you're like adding a 1/2 and then subtracting a 1/2? Or wait, do they?
So you can think of, so both of these terms have a 1/2 t squared in them. So if I move this to the, I would be subtracting 1/2 a t squared. So what is minus 1/2 gt squared minus 1/2 a t squared? Kelly has typed something and said that those two things add together. Yes, so let me write down. Kelly has put everything on the left, which is fine. Kelly has said that what I get is 1/2 a plus g. And again, you should do this on your own. If you don't see where this is coming from, you should think through the algebra on your own. Whoops, that's minus. And then she has said plus h equals 0. So we started this problem with someone saying, hey, wait a minute, the acceleration and gravity kind of ought to add together, right? And I said, yeah, but you got to show me where that comes from. This is what happens. This one is accelerating upward, this one is accelerating upward, this one is accelerating downward, and the difference between their accelerations is here. So that was the thing we knew we would get, and there we are. Cool. Yeah, it is cool. So now in the quadratic formula, right, here is my a. It's the coefficient of t squared. Here is my b. And here is my c. Okay.
You get 2 values of t.
I would get 2 values of t, yeah. Because the quadratic formula always gives you 2 answers. So, and that sort of makes sense, right? Here we've got 1, 2. But does this allow us to answer the question we started with, which is a yes or no question? Is there a value? How do I get that out of the quadratic formula? How do I get a yes or a no? I leave you to ponder that as you finish the problem, as you have things to do. I am unfortunately going to have to hang up the Zoom. I've been on my headset for a long time today. Are there any last things people want to ask about the exam or about, it's really a quiz. It's not a huge part of your grade. Thank you, Joshua. Thank you, Dinara. Thank you all so much for coming out and doing physics with us on a Wednesday night. Of course, Kelly, this is the most important part of my job. Physics 211 is not a class where there is a lecture and then you go into a cave and think. Physics 211 is a class where you practice a lot. If you think about how yes, I am completely covered in chalk, Kelly. If you think about how you learn to play a musical instrument, it's not like your piano teacher hands you the sheet music and then goes away. Your piano teacher stays with you while you practice and says, hey, you could try playing this part a little faster, or you could try playing this note with a different finger. Or if you are, playing in a band, you have a director who says, trumpets, you need to really listen to the clarinets here for your entrance. And physics is like that too. Physics is a thing that you learn with other people. It is not a solitary endeavor. We have this stereotype of Isaac Newton going into a cave and coming out 20 years later with the Principia Mathematica. That's all of this and more. But that's not how physics gets done. Physics is a conversation. Yes, Dinar, I will enjoy my peanut butter and jelly sandwich. Okay, let me answer the other questions. Kelly says, I am covered in chalk is how you feel. Yeah, learning stuff is hard, and Physics 211 is going to be a lot of work. But typically in Physics 211, almost everybody passes the class. The only people who do not pass Physics 211 are people who either don't show up to stuff, don't try to learn physics, or people who, as happened last year, who look up exam solutions on Chegg. So this class, here is let me share a story with you, if I may. I was watching a Twitch stream a couple years ago, and the person broadcasting on Twitch was an Army veteran. He had been in the military, and he had been injured in combat, and he couldn't be in the military anymore. And there was one of the viewers of his stream asked him, I am about to go to basic training for the Army. What advice do you have? Because I'm about to go to boot camp, right? And the advice that this Army veteran had for the person asking said, the people in Army basic training are not going to ask you to do anything you can't do. They know what you can do. They know what you're capable of. They're only going to ask you to do things you can't do. And, we don't have drill sergeants that shoot at people, or not shout at people in physics land, but I like to try to embrace the same idea that the things I ask you all to do in Physics 211 are all things that, with guidance, with your coaches and your TAs and with me and with each other, you all can figure out how to do. And what we're going to do in this semester is we're just going to build thing on top of thing. When you understand one thing, we'll add a new thing. And every year I have taught this class, the grades are overwhelmingly good. So if you're saying my brain feels like it's covered in chalk dust, yeah, but I promise you're going to be okay. if you work hard, if you think deeply, and but the other piece of that is if you are falling behind, if you are super stressed, please ask for help. So the syllabus says basically if something is late, you need to do it by the next Tuesday. But after that, it says if you are falling behind more than that, please ask for support because we've got support to give you. Okay, what are the other questions? Anthony says, for the quiz, do we have to go step by step or can we just write down the answer? We want you to, so every quiz question will have several parts that are walking you through the problem step by step. We want you to show your reasoning and logic, not just the final answer. We want you to explain yourself in diagrams, in words, in equations, in pictures. All of these are important. This isn't going to be like an essay test where you have to write 5 pages, but yes, there will be multiple parts to each problem that walk you through the steps. Sky says, is it open notes? You may use any notes from this class. This means you may look at videos on YouTube, although you probably won't have time. You may look at your textbook. You may look at the slides I have posted. You may look at your own notes. You may use any materials that are part of this class. So our videos, your notes, your textbook, the slides, your homework. Anthony, no, you don't have to show me what you crossed out. If you did something and you say, I don't think it's right, then I don't want to see the thing, sometimes it's helpful, but if you make a mistake, then you can just say, like, I don't need to see your mistakes. I want to see what you think the correct thing is. Rebecca, yes, you may use 9.8 meters per second squared or 10 meters per second squared for G. I am lazy. I prefer to use 10. Sky, do you have to be on camera? No, you don't. You may do so we are going to be on Blackboard Collaborate so that if you have questions, you may come ask. But, we expect for most people, you will download the quiz and we will hear from you an hour later when you submit the solutions. Any other questions?
So really quickly, for 1A, and also we did this in recitation, there was a part where when you're solving for the initial velocity, when we had our TA show us, so we have that, what is it? So we have gravity divided by 2, parentheses, the x or the d over the initial velocity times the cosine of theta squared is equal to the distance again, sine divided by cosine of theta. And what we did in recitation, somehow, like, he took the initial velocity out and then put everything over to one side and did the square root of it to get the answer in recitation. And I don't really understand how he did that.
Okay. Could you repeat that equation to me? Now I know what you're asking. I didn't think I needed to write the whole question down, but could you just repeat that equation to me and I'll write the whole thing down and then we'll talk about it, okay?
Okay. I'll use the recitation equation. So that one was 12 times tan.
Give me the variables.
Okay, so it'd be x tan theta is equal to g divided by 2 times x divided by v naught cosine theta squared.
Okay, say it again. Now I see where that came from. This is like 5 steps deep. For people who are like listening, this is a thing that Juanita has arrived at after doing a lot of algebra, and now she's got a question about algebra. So I was like, where is the tangent coming from? That's why I wasn't writing it down. But now I know where you are. So could you repeat it again? I am so sorry.
So it'd be x times tangent theta is equal to g divided by 2 times x divided by initial velocity times cosine theta, which is all in squared.
That, right? And so your question is, how did initial velocity come out of that?
Yeah.
So I would need to think, I'm trusting you on this, and rather than x, I'm going to use d for the
Okay.
distance across, just because I like to reserve x for the thing that changes with time. So the thing is, you need to get a v naught by itself, right?
Mm-hmm.
So what I would do would be to multiply both sides by cosine squared theta, because this is just the denominator of a fraction. So I can do this with my eraser. I'm going to take this here and move it over there. Actually, I'll write another line. So that gives me v naught squared cosine squared theta times the stuff I had before, d tan theta equals g over 2 times d. And was I supposed to square the d as well?
Yes. I
Yes,
forgot
I
to
was like,
mention.
where'd that go? Oh, d squared. Okay, so now I can start canceling stuff. So this step you're okay on?
Yeah.
Okay, now I can start canceling stuff. So what do I cancel?
Could you cancel maybe the trig functions?
Ah, so what is tangent equal to?
Sine over cosine.
Sine over cosine. Yep. Thought you were going to go for the easy one first, and you went for the hard one first. Okay, and now what can I do?
See, I found the hard one. I can't find the easy one.
So the easy one is to cancel a d.
Okay.
Right? But there's something you can do. So now you have cosine squared means cosine times cosine.
Mm-hmm.
So now you have cosine times sine divided by cosine. Could you make that simpler?
You can make it just cosine times sine.
Yeah, yeah. So all this goes away, and this gives me cosine theta sine theta. Whoops, and I forgot my equals sign. And I canceled that. Does that make more sense?
Yeah, it does. So then after you get to that point, you would just so to get v not by itself, you take what you've written in green and then divide that and put that under to the other side of the equal sign and then square root everything.
Yep.
Okay. That makes a lot more sense. Because I saw in recitation, I was just following, and I was like, I don't really know how this works, but you're the TA, so I trust you.
See you later, Kelly. Thank you so much for coming by. Yeah, Juanita, so often, like, here's the thing. It is impossible to follow someone else's algebra.
Yeah.
I mean, maybe the math majors can do it, but when I was a PhD student, I took a math class. As a PhD student in physics, but I took a math class, and I could not follow these people. Like these mathematicians were like, oh yeah, and they would just fill the board with chalk, and I'm like, wait a minute, okay, they canceled this, and then they're like, oh yeah, and this integral is this, and I'm like, I don't spend my days doing integrals, I spend my days doing other things. And so with algebra, if you can't if someone else says an algebra thing, like if I say an algebra thing in class, always just stop me and say, hey, where did that come from? And if sometimes I may be running low on time, because, I have to let everybody go at 12:20. If I don't have time, I will say, think about this on your own, but have faith that you can do the algebra on your own, because you can. All you needed to do here was to, you identified the difficult part, which was what to do with tan theta.
Okay, thank you.
Sure. Anything else I can help anyone else with?